Yeah, that was the test of the tornado siren. Well, good day, everyone. My name is Les Johnson, and I'm here representing the Interstellar Research Group to provide a webinar about something that I think is a big issue that we need to be thinking about. I won't say worrying about, and that we as a nation, and in fact, everybody on Earth should be aware of and pressuring their politicians, companies, and everyone else to be taking measures to make sure that disaster doesn't strike. Today, the Interstellar Research Group is thinking about the future of the human species and how we will become an interplanetary civilization and one day reach the stars. The IRG is dedicated to taking those first steps and things that we can all do today, regardless of whether you're a scientist or engineer, if you're in policy, or just an average person who's interested in space technology and space exploration. I would encourage you to check them out at irg.space. But today's webinar is the hidden threat to America, what losing space would mean to us. And I have a book on that topic called Sky Alert When Satellites Fail. But let's talk about what this is about and what this means. Michael, I'm going to share my slides now. All right. So my contact information is there, Les Johnson, irg.space, and the website for the IRG is irg.space. A little bit of background about me. So you wonder, who is this guy and why is he talking to me? I am a physicist. I've been a space enthusiast as long as I can remember, and I've spent the last 35 years working for NASA at the Marshall Space Flight Center in Huntsville, Alabama, where I currently serve as the Chief Technology Officer. Now, I say that, but I have to give a very clear caveat here that today I'm taking vacation time and I'm speaking as a private citizen, and these views do not represent my employer. They are only mine. So if you have any questions or concerns or problems with that, reach out to me, not my employer. Thank you. So let's begin. Today, we've got more than 12,000 satellites in orbit. Now, that's an astonishing number that few people would have believed possible just 10 years ago. And the statistic is, and this is just for your edification, that over half of these have been launched in the last decade by SpaceX. Now, space is going to get a lot more crowded, and we're going to get more dependent on what we have in space than we are today. And most people don't even realize how dependent we are. So the first part of this webinar is I'm going to outline a little bit about what we have in space, what the threats to those satellites are, and how big that threat is in the last decade. Then I'm going to talk about what the implications would be if something were to deny us access to the data and information coming down from these satellites, and what that would mean for you and me as we try to live out our daily lives. A lot of people don't realize that space is intimately tied to our health, our well-being, our economy, and our wealth as a nation, and in fact, the wealth of the nations of the world. You can see in this curve what I mentioned about the rate of satellite launches increasing, and this slope of the curve is not going to change much over the next few years, because in addition to the Starlink that SpaceX has been putting up, there are competitive satellite constellations coming from other private companies in the USA, notably Amazon, other countries, China, Europe, you name it. They're all launching more and more satellites to provide the same communications and information infrastructure that we currently enjoy here in the US. Now, since 1960, when we first launched space satellites, there's gotten to be more and more junk in orbit. See, what happens when you launch a rocket, by the way, don't let the size of that panic you. I'm going to run that slide again. If you look at this picture, don't let the size of the dots panic you. This is not the scale. If I were to show dots to scale of the Earth, you wouldn't be able to see them. Space is still really big. But this is not a chart of the spacecraft we have in space. This is a chart of what's called orbital debris. Now, orbital debris are things that are created by us, that are created by us humans as we launch rockets to space. These are like old dead satellites for big things, rocket stages. It's all the way down to wrenches that astronauts have let go of while they were servicing spacecraft, to some spacecraft that accidentally broke apart and broke into 1,000 pieces, which are orbiting the Earth at 8 kilometers a second in random directions. They're the result of the Chinese blowing up a satellite as a part of an anti-satellite test that contributed thousands of pieces of debris. And it goes on and on. And yes, some of that's pretty disgusting. It includes human urine that's been frozen and as it was thrown out of spacecraft, particularly during the 1960s and 70s, all the way out to little radioactive droplets from cooling systems that have leaked aboard Russian nuclear-powered satellites that are no longer functional. And I do want to remind everyone that at the end of this webinar, we will allow time for questions. You can put the questions in the comments bar, and I'll try to address them as we go along. Well, not as we go along, at the very end, and I'll allow time for that. And after this webinar is over, if you have questions and you're watching this later on, you can feel free to reach out to me at les.johnson@irg.space or reach out to the Interstellar Research Group and they'll put you in touch with me. So this is the debris problem. There are 500,000 pieces, 10 centimeters, pieces of debris that are 10 centimeters or larger. And remember, 2.54 centimeters per inch. So there are 500,000 pieces of debris that are about 3 inches or larger. That's a lot. And the probability of them colliding with an existing satellite is real enough that they are all tracked, and spacecraft providers who have functioning satellites have to maneuver their spacecraft out of the way sometimes to reduce the risk of being hit by junk. That includes the International Space Station, which is a very large facility in low Earth orbit. It used to, when it was first launched and occupied, have to do a maneuver every now and then. Now it does maneuvers almost every day to get out of the way of space debris. If something moving that fast were to hit another satellite, it would be like a bomb going off and create thousands of other pieces of debris. And therein lies the problem. There is a NASA researcher who has since retired. His name was Kessler. And what he calculated was that with all of these spacecraft up there, and if they collide with each other, each collision will produce thousands of more pieces of debris, each 10 centimeters or larger, traveling at 8 kilometers a second, which would then imperil other satellites. And you can imagine that eventually you might reach a point where you have a chain reaction. A piece of debris breaks apart a satellite, creating more debris, which hits more satellites, which creates more debris. And eventually you get a cloud of debris circling the Earth that makes it difficult for any spacecraft to survive. Now, this is known as the Kessler effect, named after the NASA scientist who first calculated the probabilities of this happening. And I don't know about you, but if I were a medical doctor, I would not want a disease named after me. And I don't think that Dr. Kessler is real eager to have the apocalypse of space named after him either. But that's what it's become known in the literature. And if you want to learn more about that, look up the Kessler effect. Fortunately, the nations of the world are requiring their commercial companies to try to mitigate this problem, not create as much debris in the launch. And all spacecraft today are designed to re-enter within 25 years of their end of life. In other words, come into the atmosphere and burn up so they don't stay up there dead to create future debris. And that's a really good thing. And most countries of the world have signed a treaty to do this. But there are other things that can create debris in space beyond just the natural decay or an accident. Space is not going to be an uncontested area should there be a war between countries that have access to space. Now, the USA and Russia have each tested anti-satellite weapons. The US has one that flies on it's a missile that's launched from a high altitude aircraft that flies into space and would hit a satellite. The USA tested that on an old dead satellite, but on one that when it broke into a lot of pieces was already on a trajectory to re-enter the atmosphere. And in a very short period of time, all those little pieces came into the atmosphere and burned up, and it didn't pose a risk to other spacecraft. Unfortunately, the Chinese did a test in 2010 timeframe where they increased the amount of orbital debris dramatically. If you look at this chart over here, when they destroyed this satellite here, the amount of debris particles increased dramatically. So much so that the Hubble Space Telescope had to start maneuvering out of the way of some of the debris they created. And prior to that test, they didn't have to do that. And the reason that happened is because the Chinese didn't pick a satellite that was about to re-enter and burn up anyway. They picked one that was at a higher altitude, and pieces of debris at some of these higher altitudes could be up there for 1,000 years or 10,000 years. That's a real problem. So let's hope we don't have any more ASAT tests. Now, I do want to mention that it won't have to be something sophisticated like a missile. Any spacefaring country, which would include North Korea, Iran, and others, could do something as simple as launch a rocket that has a small amount of conventional explosive that knocks out a whole host, tens of thousands of ball bearings that would have the same effect as creating a miniature Kessler effect and could take out satellites and cause a full-blown Kessler effect if that were to happen. So the risk is there. Let's hope that we don't get conflict that leads to space, because all too easily and all too quickly, events could unfold to get out of control and cause us to lose access to a lot of these satellites that are orbiting the planet. Now, there are natural things that could imperil our satellites. We all really enjoy having sunlight, especially now that it's spring here in Alabama. Beautiful day, sun shining, enjoy the heat and light from the sun. But remember, the sun just is emitting more than just heat and light. The sun is also sending out something called the solar wind. Now, the solar wind is a stream of high energy protons, electrons, and a little bit of helium streaming out from the fusion furnace that is in the sun to all of the solar system. It's constant, happens all the time. It's not usually a problem here on Earth because we're protected by the Earth's magnetic field. If you're a Star Trek fan like me, think of the magnetic field as a deflector screen that electromagnetically repels most of the solar wind to keep it from coming down to the Earth and irradiating us with the radiation that comes from that. If you were a person in space and you're out there for a long time out of the Earth's magnetic field, that radiation could be a problem. It's also a problem for spacecraft, but it's a low-level chronic problem that you can design around by putting shielding on the spacecraft to block these particles from hitting. The problem is the sun is not always so benign. You may have heard of something called a solar flare. Scientists typically call the ones that are bothersome coronal mass ejections. And that's exactly what it means, is out of the sun's corona, a layer of its atmosphere, a whole lot of solar protons, mass, is ejected into space. Essentially, the sun burps. And when it burps, it sends a cloud of much higher energy protons flying out of the solar system very, very fast, not quite at the speed of light, but pretty fast, faster than anything we can build. And these burp clouds of solar protons are bigger than the Earth. They are enormous. And most of them travel out of the solar system in some random direction and never bother the Earth or any of the planets because space is really big. But sometimes a coronal mass ejection will send a cloud of this radiation directly toward the Earth. When that happens, it can be beautiful. For instance, the aurora. I don't know if you've seen the aurora last spring and a year ago spring, there was a lot of solar activity and some very large coronal mass ejections. And you could actually see the aurora as far south as Alabama and Tennessee, which I'd never imagined I would do. This picture was not taken then, but I did take this picture in Alaska in the winter of 2022 that shows the aurora over a cabin I was staying in. And here is my cabin. And this was a photograph with an iPhone. It was gorgeous. Now, what is this? This is radiation that's already trapped around the Earth, okay? That as the solar storm hits, a lot of this radiation gets pushed down in the atmosphere where it interacts with our atmosphere, ionizes elements in the atmosphere, and it glows. And a really bad storm will push it down further, ionize different elements, which gives you the color, different colors in the aurora, which makes it pretty. And this was a very pretty energetic storm. It was awesome. It was extremely cold. It was windy, 18 degrees. I was standing on an ice pack. I was cold the rest of the night, but I got a beautiful view and took some great pictures. This was caused by a solar storm. I got to be careful. Most solar storms happen. They're benign. They're not that big of an issue. But solar storms might not be so pretty because when there's a bad solar storm, airlines reroute flights from flying over the Earth's north and south pole. And they do that to avoid the radiation that's coming in from a higher intensity at the Earth's magnetic poles, which causes that problem. So it affects the power grid, it affects corrosion on pipelines, and it's a problem. And it's so much of a problem that NOAA, the National Oceanic and Atmospheric Administration, issues warnings when these solar storms are coming in, so satellite providers and utilities can take a clue and take care of not being affected by that storm. Now, I'm going to pause from the presentation here for a minute to let you know a little bit more about the Interstellar Research Group and how you can get involved. Now, the IRG, and I'll enlarge this so you can see this slide, we have symposia, and these symposia happen roughly every 18 months. Our last one was in 2023 in Montreal, our 8th symposium. Our 9th symposium is going to be in Austin, Texas, near UT Austin. And it's going to be at the AT&T Conference Center, October 12th week in 2025. And at this meeting, we will have presentations, papers presented not only by scientists and engineers, but by space lawyers, space policy experts, philosophers. We typically have some kind of an art show because space art is something people appreciate. In other words, these meetings are open for everyone who's a space enthusiast. Some of the presentations will be deeply technical, might go over your head. Many of them will not be. There'll be science fiction writers present. It's a great thing to attend. If you think you'd like to make a presentation at the symposium, please go to irg.space, where we have information about it and our call for papers. But you better hurry, because the deadline for submitting abstracts is coming up, and it's June the 1st. If you miss the deadline, I can't promise we'll consider your paper. Try to get it in by June the 1st. That'd be great. We'd love to have you there. If you don't feel like making a presentation, but you just want to go and learn, you are more than welcome to sign up to participate and attend and enjoy yourself at the symposium. If you have any questions, reach out to the Interstellar Research Group at irg.space. Now, I'm going to talk about a rare event. These solar storms, which I was referring to, that can cause problems for aircraft and utilities because of the radiation that does come in at a little bit higher intensity during a solar storm than normal, still not much of a threat to us on the ground under normal circumstances. On a basis of roughly once every 500 years, it's not like clockwork, not once every 500 years on a clock, but approximately once every 500 years. You could have 2 in 1 year and another one not for 1,000 years, right? There are really bad coronal mass ejections, enormous high energy solar storms. The last one we recorded was in the 1800s, 1859, I think it is. Yeah, 1859. And it was observed scientifically by an astronomer named Carrington in the UK. And it was observed by the Chinese, who did drawings of this. Well, what happened is this storm was so intense that the radiation and the Earth's magnetic field were compressed so close to the surface of the Earth that the changing magnetic field across the latest technology at the time, the telegraph lines, produced currents in the telegraph, causing some of them to short out, some of them to not need power to work, and they started basically clacking like crazy. Well, once the scientists did an analysis of what that energy level would be, didn't imperil human health, but it affected the electronics of the day in 1859. They assessed that should that happen today, okay, should we have another Carrington event today, it could potentially induce spurious currents in the electrical grid and take out the power grid. It could zap the electronics in your computers and your cars. It could destroy the functionality of all but the military-grade satellites in Earth orbit and basically destroy our entire infrastructure of power, and all of our satellites would go down. Now, don't panic. The probability of this happening is extremely low, but it's not zero. Happens about once every 500 years. Something to be aware of. If it were me, I'd be hardening all of our satellites to protect against this kind of an event. Because you don't want to lose that infrastructure. That would be really bad. I've also mentioned early on about space war. On the picture at the left is a picture of an aircraft launching a missile. I don't know if this was the actual anti-satellite test that the US did, but that's how we've tested our systems. I've not been involved in that directly, but I've read about it. Would go up into space and take out a satellite and cause a problem. There's something else, though, that scientists and politicians have worried about since the height of the Cold War, when the USA and the Soviet Union were both massively producing and testing nuclear weapons. And that is the notion that someone might detonate a nuclear bomb in space. Now, if that were to happen, it wouldn't look like or have the same effects as a nuclear bomb on the Earth. On the Earth, the damage is primarily done by the superheated air that's produced when the bomb explodes and the outward pressure wave of the explosion. You've seen the videos, pretty sobering, where cities could be destroyed by these on the ground. Even if we didn't have a nuclear war where someone detonated a nuke on the ground and they just did it in space, it would put so much radiation into the Earth's magnetic field, and the flash of the nuclear radiation from the explosion itself combined with all that could put enough radiation in space to imperil most, if not all, of our satellites that we have there. It is a very big concern. Now, the treaties that we signed with this then Soviet Union that the Russians are obligated to, and many other countries today, not all, called the Outer Space Treaty, says we can't put these kinds of weapons in space. Just because we're not supposed to doesn't mean people don't. And there is concern, and this is a fairly new article, you can see here, it's dated April 12th, 2025, about a concern that the Russians are doing just that today. And in fact, just prior to that April headline, and you can look this up in your news feed, there was a Russian rocket launched with a spacecraft that the intelligence community, publicly available information, thinks contains a nuclear weapon. And this would be some kind of an offensive capability to take out the satellites we have in space, and that would be a very, very bad day. Let's hope the Russians aren't doing that, but it is a big concern, huge, in the international community right now. So let's talk about what the effects would be if we were to lose satellites. Well, I'll start with probably one of the most obvious, which is GPS. Now, most of us interact with GPS on our cell phones, right? Or if you're a little older, you may have at one time had a standalone GPS device called a Garmin, or a competitor to Garmin, that takes data from 3 to 4 satellites that are in line of sight and does basically trigonometric, big word for saying it looks where you are, and it can tell by the signals coming from all these satellites exactly where you are within a meter or less, anywhere on the surface of the Earth. All you have to have is a GPS receiver and line of sight to these satellites. If you're in a big city, you may have noticed your GPS doesn't work as well, kind of puts you on the wrong street, wrong store location sometimes. That's because some of the GPS signals are being blocked by buildings that stop you from having a direct line of sight with enough satellites in space to get that kind of positioning. So that's global positioning in a nutshell. These satellites were launched by the US military, and at first the high-resolution GPS data for location pointing was only available to the military. They've loosened that up. It's now available to the average user. The Chinese have their own system, multiple satellites, tens of satellites. The Russians have their own system, tens of satellites. The Europeans have their own system, tens of satellites, just like GPS, to do this kind of position knowledge that you have. Why is that important? And what would be the impact if we were to lose GPS? Well, first of all, the cell phone, yeah, you would lose Google Maps, Apple Maps, Waze, whatever your preferred software is. But you would also lose the functionality of your cell phone. This would become basically, for anything to do with communications, it would become a brick. Now, you're probably wondering, why is that, Les? Why would that happen? Well, it's not because your cell phone signal is necessarily going to a satellite, although if Elon Musk is successful, your phones will be able to talk to his Starlink satellites. They may already be able to do it in some locations, and I know that there's now an SOS mode to go to sat communications on your iPhone. Should you have an emergency and you don't have access to cell service, you can get access to a satellite for a 911 call, essentially. But the reason is because all of the GPS repeaters that are on cell towers, or your cell phone repeaters that are on towers around the world, to route the data correctly from tower to tower between somebody calling you from London while you're in Omaha, Nebraska, that data has to be routed in the right order so it's not just noise. Your call, your voice of your aunt or your grandfather or whoever you're talking to is routed in the cellular system. And in order to do that, each bit of data, not bit, byte of data or group of data, has a timestamp on it that's extremely precise. That timestamp has been agreed to by every cell phone provider in the world as the precise time. Everyone uses that clock. And how do they synchronize those clocks? By GPS. So if GPS goes down, the universal clock goes out, and the ability to properly transmit and recover the data from your cell phone from tower to tower is potentially not there anymore. So you'd lose that kind of communication. So you might be thinking, okay, Les, what's the big deal? Okay, we'd be inconvenienced, yeah, but you haven't convinced me that that's essential. That takes us back 20 years, but we were fine 20 years ago. Well, maybe. Aircraft are now going to what's called next-gen air traffic control. It used to be that there were a series of towers out there with radio transmissions that allowed aircraft to triangulate and know their position as they flew around the world. Those towers, in many cases, are not there. They now use GPS because it's much better accuracy for aircraft to fly from place to place. So if we were to lose GPS and next-gen air traffic control would go down, commercial airline traffic would pretty much ground to a halt. And it's worse than that. Goods and supplies are flown by cargo plane from all over the world. That includes not only things that are going to be in your local store, but in your supermarket, food, essential medical supplies, otherwise come in by cargo aircraft. A few years ago, I got a tour of the FedEx distribution center in Memphis in the middle of the night when they take over the Memphis airport and sort all the overnight packages that come in from all over the world to send them to their final destination. An impressive operation. All that's made possible by GPS. Precision flights arriving on time where they need to be. And there's more. GPS and something called positive train control. About 2 decades ago, there was a tragic railroad accident where a freight train hit a passenger train and some people died because they didn't have really good understanding of where all the trains were. They had an old system to figure out what train was where and how fast it was moving. So they now came up with something called positive train control, where there is now a grid that maps the location of every train in America by how? GPS. The GPS transponder on the train says, I'm here. That's communicated to a central location. They're able to track where all these trains are, how fast they're moving, when they're going to get to intersections, when they need to do the routing. And if you've ever seen trains go by with all those railroad cars of supplies, you know that vital supplies are on those going into major cities all over the world. Little known fact, I've heard this, New York City and other big cities are about 3 days away from starvation. And what that means is the grocery stores on average are emptied out every 3 days. And if it weren't for the trucks coming in at night, bringing in food that's been brought to the communities by either truck, navigating by GPS, or train, navigating by GPS, or airplane, navigating by GPS, won't arrive, and those supplies wouldn't get out. So you could have a really bad situation in cities, and something as simple as the food supply, should you lose access to GPS. Big deal. Now, I've already mentioned cell phones. There's functionality in your cell phone just beyond phone and position location. Without the GPS data coming to the cell towers, that'd be a big problem. Now, one other thing that's been learned, and this is a reason that countries were testing anti-satellite weapons, goes all the way back really to the first Gulf War. A lot of people call that the first space war, because that was the first war in which the U.S. confronted an opponent, in that time, Iraq, where the U.S. had GPS and all of our units knew exactly where they were, every tank, every soldier in the field, every aircraft, everybody knew where everybody else was at, once they got intel as to where the Iraqis were, who didn't have access to GPS, everybody else was at, didn't once know they got intel as radio each other and other methods, it was a rout. And that was because knowledge is everything in a war. You also have, as this missile coming out of this aircraft shows you, we have precision-guided munitions. Warfare today is not fought like it was in World War II, where you basically took an airplane, loaded it with bombs, and dropped enough bombs in the hope that you actually hit something that you want to destroy in a war. All this load of bombs on an aircraft could be replaced by one precision-guided missile. And in many cases, those are guided by GPS, although there are other methods for precision munitions. So even fighting and executing a war has changed dramatically in the last 50 years. So going back to the comment I made, this is a picture from the first Gulf War. It's called the First Space War. And that woke up a lot of our potential adversaries about what capabilities they too needed to have in space and how to threaten our capabilities, as I've described previously. Now, it's not just used by the Army and the Air Force, it's used by the Navy for locating ships and the aircraft that they have flying from them. And if you want to prevent war, which in my opinion is the most important thing, spy satellites. We've had spy satellites since the earliest parts of the space program. There were a project called Project Corona back early in the space program, where we had spy satellites flying over the Soviet Union, but they didn't have digital cameras and radio to send the data back. They had actually a physical camera with film, and they would take pictures, and then the film would be put in a canister that re-enters and survives not burning up in the atmosphere until it lands on the ground. People retrieve the film, go to a photo lab and develop it, and see what's on the film. So that was early in the space age. We do this today, and today that's how we were able, the US and the Europeans were able to tell Ukraine that they were going to be invaded by Russia, is because they could see the massing of Russian troops on the border to do that. Well, now I'm going to take another break, take a deep breath, and tell you about another activity, if you're interested in IRG and interstellar travel, that you might be interested in. And that is the publication of an interstellar monograph series that I had the privilege of co-editing with another member of the Interstellar Research Group, Ken Roy, who's a nuclear engineer, worked at Oak Ridge National Labs, and he's now retired. What we found was that in the field of interstellar studies, there were no good textbooks or technical books. Yes, many of these are filled with equations, not all, that take you through all of the technologies, societal elements, space law elements about interstellar travel, propulsion, power, communications, life support. How many people do you have to take if you're building a self-sustained world ship? How do you propel a spacecraft up to 10% the speed of light? Things we can't do today, but we'll have to do if we're ever going to reach the stars, that are within the realm of known physics. No science fiction here. I write science fiction. That's not what this is. These are technical books. Now, the first two have already been published. The publisher is Elsevier, a scientific publisher. The first one is Interstellar Travel, Purpose and Motivations. Those are the things you do to get ready to go, the technologies you have to develop. The second book, which is also out, is called Interstellar Travel, Propulsion, Life Support, Communications, and the Long Journey. And it's all about what you have to have on your spacecraft, how you survive it, either robotically or with people, and all the things to keep a crew alive on an interstellar voyage going to a planet around another star. The final volume in the series will be published this June from Elsevier. It's called After Arrival. And this is something I think is overlooked by many. And that is, let's say we're able to go to a planet around another star. The likelihood of finding an Earth 2.0 is almost zero. So what do? How do you terraform planets? How do you live on a planet like Mars or Venus or an asteroid? How do you adapt? How do you adapt it for us? Great series, I think. Don't really get any money for this. This is a labor of love for us, contributed by many authors who are experts in their fields, including the ex-NASA chief technologists, university researchers, company researchers in the industry and universities. Ken and I are just the editors. The content came from probably 60 or 70 different specialists around the world. Highly encourage you to consider that as in your interstellar education. Now, for the last segment of today's webinar, I'll continue with what we would lose out on if we lose our satellites. Of course, if we lose our cell phones, we'd also lose sat phones. The whole Elon Musk satellite internet constellation that is Starlink would go down and would be lost. And I'm going to tell a little anecdotal story about what got me interested in this topic and what I think would be the most consequential of the negative effects should we lose our satellite capability. This happened 10 years ago or so. I was coming home from work, and I had to stop at the local Dollar General to pick up some food to bring home. We're going to cook for dinner. Our Dollar General has a market, which means they have fresh produce and fruits and things like that. So I stopped, picked up some items, was in the line to check out, and I noticed that there were two lines. One was really long, and one had no one in it. And the one that had no one in it was the manager, and he was telling everyone, if you have cash to pay for your purchase, come to my line. If you are credit card or check, our VSAT is down, and we have to wait for it to come back up so they can clear the credit card or the check. So the line to check out for people who didn't have the cash in their pocket was pretty long. And I walked straight up to the counter because I happened to have a little bit of cash in my pocket. And I asked the manager what was up. And he explained that when they run your credit card or you write a check, if anybody still does that, telecheck, they have to quickly make sure it's a good account and not a fake, right? So they have to run it, and some places do it through the internet, but they were concerned about security of the internet in doing that. And so many stores, including Dollar General at the time, had a direct satellite link on their roof, something called a very small aperture terminal, a VSAT, which communicated to satellites to do the authorization of credit transactions. Their VSAT connection was down, so they couldn't process credit cards. So, being curious, I asked him about other places, and he goes, oh yeah, when you drive home, look how many businesses have small satellite dishes on their rooftop. That's not to get DirecTV in their break room. That's VSAT. I did some research, as I'm prone to do, and I found out these are just a few of the companies that at the time and potentially today still do their financial transactions when you're in the store clearing your credit card by VSAT, by satellite, okay? And it's even scarier than this. Well, it's not much scarier than this. So imagine if we lose our satellites and you don't have much money, how are you going to pay for things? How are you going to pay for gasoline? How are you going to pay for food, even if it's in the store? How are you going to get money out of your ATM? Because banks communicate by VSAT and exchange of funds overnight exchange of funds between all the world's big banks, which flows into your little bank, which affects how much money they have and their ability to do transactions, okay? The New York Stock Exchange uses VSAT, or used. Central Bank of India, Bank of China, many American banks. In my opinion, if we lose our satellite infrastructure, our economy stops. We don't know what's happening with weather without satellites. We all take for granted that we can pull up our phone, get a pretty accurate weather forecast for the day, for the week, to plan our vacation, to know if there's a hurricane coming. You lose space, you lose most of that weather forecasting capability. All you have to do is go back and read about the hurricane that hit Galveston Island in the early 1900s, Galveston Island off the coast of Texas, where they had a pretty normal day. And by nightfall, they had waves and water covering most of the island, and hundreds of people died because they didn't have the ability to forecast the weather accurately. You can track man-made disasters, burning forest fires, the fire that was in California, the fire that was in Hawaii. You can monitor that from space and provide evacuation orders and help with recovery efforts from doing that, among many other things. Needless to say, the threat to human spaceflight is very real. If you were to have a big solar storm or lose satellites and they came crashing into the space station, you'd have to abandon the space station and bring people home. We also use satellites for remote sensing to monitor what's going on the planet, sea level waters, ice levels, all of the things that are remote sensing. Companies use this to locate oil deposits. They use it to find resources. It's used to monitor crop growth and the spread of diseased crops from space using something called multispectral or hyperspectral imaging. It's a huge deal, and it would affect our ability to grow the food that people eat, even if you could get it to the stores. It affects our ability to understand the impact we're having on the environment, climate change, those kinds of issues without satellite observations. Television, for those of you that don't just stream, you might still watch television news or listen to NPR or your favorite radio broadcast. A lot of that goes off satellite for distribution locally. So the big users of satellites initially were the television networks because that was the only way they could get reliable information around the world easily by bouncing data off satellites. If you go to a TV station near you, you'll see lots of satellite dishes because they get the network feed off of satellite before it's piped into your home for you to watch. And of course, things like satellite TV, direct TV, all that would disappear. Broadcast television and radio, for the most part, except for local stations, would go down, not be available. Just-in-time manufacturing. A lot of companies save money because what they do is they don't keep a lot of supplies on hand in their manufacturing. They rely on the supply chain and the infrastructure to have that truckload of widgets arrive just in time at the factory to be turned into the spare parts for your car or the repair for your air conditioner or refrigerator. And this just-in-time inventory requires on precision tracking of where all the trucks are, what's in them, when they're going to arrive, goes back to GPS, communications, all the things we use satellites for that would go down. And that does include food, medicine, and supplies. Just as an aside, satellites have been hacked before. So another way that we could lose spacecraft, although probably not in mass, is that bad actors get into the communication system and they hack the satellites. It's for that reason that all satellite communications now and control communications for the spacecraft is encrypted to try to keep people from taking over satellites. There are rumors out there that more than one US government satellite over the last 30 years has been hacked and someone else actually temporarily took control of them. Pretty scary stuff. Things we need to be aware of. So I'm going to reach the conclusion of my presentation and be ready to take some questions. And I'll just give you Les's opinion, strictly my opinion, not those of anyone that I work for or work with. I believe that if we were to lose our satellites, at best, we would have a Great Depression. Credit card and banking stops. Manufacturing and goods distribution is mostly stopped. Transportation systems are grounded. The economy grinds to a halt. We have the interruption of the distribution of necessities from farms, shipping of food, food distribution. What that could lead to is people dying. So at best, we have a Great Depression. At worst, we have a lot of people dying, accompanied with a Great Depression. Now, we don't want war, but when you don't know what your opposition is doing, all the systems go down. In a world of hair trigger thinking, artificial intelligence running systems, and people scared when they lose certain key communications, it could accidentally trigger a war. Don't be afraid of this. Be aware of this. This is something that our leadership in the US, abroad, other country of the world needs to be aware of. And you, who are probably a bit of a space advocate listening to this webinar, the next time one of your friends comes up and challenges you and said, you know, what good is space anyway? Why do we need to spend all this money in space? The answer is the money's not spent in space. The money is spent to build the things that go to space. It's spent here on the ground. And the economic return that we get and the peace and security that we get, the convenience we get, the economy that we get is dependent on this space infrastructure. Without this space infrastructure, your daily life, as you now know it, would be impossible. So the next time someone is debating you or challenging you and saying, oh, we don't need to spend all this money on space, you need to set them straight. These investments in space development and exploration by governments and industry have led to the conveniences that we have today. And these kind of investments are laying the groundwork of how we might one day reach the stars. So my last slide for today is a blatant commercial message for the book I wrote in this topic called Sky Alert, When Satellites Fail. It's published by Springer. So this presentation summarized some of that. I would encourage you to go out to the Interstellar Research Group at irg.space. Check us out, figure out how you can become a member. Join us in Austin for our next symposium. We'll have one in 2026 in Europe as our second European Interstellar Symposium. Our first one was last year in Luxembourg, so we're excited about that. The organization is now Interstellar. If you're interested in me and my writing, you can follow me by going to lesjohnsonauthor.com, lesjohnsonauthor.com, where you can find links to my social media presence. I'm on LinkedIn, TikTok, Instagram, YouTube Shorts, you name it, you can find stuff out there. The IRG has a fantastic series of videos on YouTube that captures the lectures from our previous symposia. I mentioned this is our 9th symposium. Most of our previous symposia we have recorded and made the full lectures by participants available on the Interstellar Research Group's YouTube channel. You can find some of my lectures and some of mine by going to my social media. These are great resources. I urge you to take advantage of them. So to conclude, I'm Les Johnson, your friendly neighborhood rocket scientist and spokesperson for the Interstellar Research Group. Thank you for listening today. We look forward to hearing from you, and we'll see you in Austin.
Thank you.